Hi, this is Nilton from craftofprogramming.com, and in this video I'm going to cover the details of the JUnit 5 architecture as well as the new extension model, which is key or core of a feature of JUnit 5. So we're going to cover the improved changes in terms of the modularity in JUnit 5. Its architecture, which is much cleaner and simpler. And we're going to cover the extensibility model of JUnit 5, as well as the compatibility that aids, in the migration from JUnit 4 to JUnit 5. So this is a slide which is due to Mark Phillip from JUnit 5 team, and this is basically to highlight the problem of JUnit 4. So the issue is that JUnit 4 had, as you can see, a single monolithic jar, which you as a test implementer would depend upon, or you as an IDE, builder would depend upon, or if you're writing some build tools like Gradle, Maven, you would depend on that, or if you have a third-party testing framework like Spring, you would depend on that too, or if you're writing some JUnit 4 extension, you depend on that. So this dependency on a single monolithic jar was, an issue for the library to evolve. So in this new architecture, this is again a credit to Mark Phillip for the diagram here. You can see that there are basically a much cleaner API here. So you as a test implementer, you would be basically using the Jupyter API, which is here in green. So the only thing that you really need to depend on, and you should care, is to depend on the Jupyter API jar. So that's the key dependency that your tests are going to depend on. And the vintage in yellow here is basically provided for backwards compatibility, and this is so that existing JUnit 4 tests can run in the new platform. So, and also they created this platform here in red, which basically enables the people that implement build tools like Maven and Gradle, as well as the IDEs like IntelliJ and Eclipse. They would basically need to have the access to JUnit 5. They would depend on the platform. People that write tests would depend on the Jupyter API, and old JUnit 4 tests would depend on the vintage API. And there is also third-party here dependency. So notice that the dependencies here from for example, if you're writing a JUnit 5 test and you depend on the Jupyter API, notice that the Jupyter API, you depend on the Jupyter API. And you don't care about what's under. Under the hoods, you see that there is a Jupyter engine which effectively implements the API. The Jupyter API is a jar that mainly contains just interfaces. So the implementation of those interfaces are on the Jupyter engine, which then talks to the platform engine to actually run your tests. And the JUnit platform launcher here in the platform, as you can see, basically is the way to launch the tests, and that's how an IDE like IntelliJ or Eclipse will use to launch your tests. So they give the tests to the launcher, which then tells the engine to run them. And this surefire provider is for Maven to be able to run a JUnit 5 tests in the platform or in the engine. And the Gradle plugin, again, is to run Gradle tests. So that's a dependency for these two Maven and Gradle build tools. The other one here that you see, JUnit Platform Runner, is basic for forwards compatibility. And this is so that old IDEs that don't yet support JUnit 5, you can basically run JUnit 5 tests. So that's a way for forward compatibility. But the main thing that you should be concerned here is that there is now a clean, neat separation of concerns, a clean, neat, architecture where people that are writing tests just depend on the Jupyter API jar. People that have old JUnit 4 tests just depend on the vintage engine via the JUnit 4.12 jar. Platform, implementers like IDEs and build tools depend on the platform, and there is a third-party dependency here for people that are writing, third-party, frameworks that integrate with JUnit. They would depend on the platform as well. So now let's cover the extension model, which is another big change in the JUnit under the hood. So, and this addresses the drawbacks of JUnit 4 in terms of how the extension model was handled. So, as you can see here, there were two ways that you could extend a JUnit test. One was via runner, another one via rule. And the reason why they were competing is because the runners basically. As you can see here, there were basically categorized in terms of graphical runners, which were supported by any IDE like IntelliJ or Eclipse, and this is what enabled you to create a JUnit test, and then just run it, or go to a package or an entire project and just run all of those tests. So when you do that, the JUnit, the IDE was creating a graphical runner to basically run your tests. So then there was this other way that you could use the run with tag. And the run with tag basically was a way for you to use either a built-in runner or a custom runner. So we had the default runner, which is the block JUnit 4 class runner. We had categories, which was a way to categorize tests, and you could basically include and exclude, a test suite like that. We had parameterized tests, suite of tests, and also experimental runners with the enclosed, and obviously third-party runners. And this was a way that third-party tools, like for example Spring, you could integrate with the JUnit via this runner, mechanism. So it was flexible in a way, and it was powerful because you could do all of those things. But one big limitation was that you basically could only have one runner per class. So, for example, let's say that you want to use categories to filter certain tests, but you wanted to use parameterized tests as well. In JUnit 4, you couldn't do that because you could only have one runner per class, and both categories and parameterized tests are runners. So that was a big limitation of the runners. And then I think JUnit 4.7 introduced rules as a way to address the shortcomings of the runners mechanism. So rules are basically a really nice way to extend or to customize and to extend the behavior of a test. And when JUnit, and you could do that at the test method level or at the test class level using the @rule annotation or the @class rule annotation. And JUnit 4.7 introduced the temporary folder rule, error code collector rule, test name, timeout, expected exception, class rule, external resource rule, and rule chain. And these are covered in this course. I have a lesson on rules. Please refer to that. And one nice thing about rules is that in a single test you could combine them. More than one rule, unlike the runner. The issue or the shortcoming with rules, as you can see, was that you could either apply a rule at a single rule at a method or at a class. So this was a shortcoming of rules. And because of this issue of, so you had these two ways to extend JUnit via runners or rules, and because of the limitations that they had, JUnit 5 introduced a completely new extension model using the extended with or extend with tag. So this is supposed to be the way that you extend the behavior of tests, and this should supersede or replace rules and runners in JUnit 5. So as you can see, unlike rules, you can apply the extend with at a class level and at a method level. And unlike runners, they can be combined, which is something that rules provided. And you could also define meta annotations or your own annotations to have highly expressive tests. So again, the key takeaway here is that JUnit 5 does not support runners anymore. There is limited support for rules. And you should really be using the extend with mechanism as the single extension model in JUnit 5. So the extensibility model in JUnit 5 is basically comprised of these three categories. You have the conditional test execution, general purpose extension points, and extension points which are tied to the life cycle. So these are basically just interfaces that you would have to implement to customize, the callback behavior. So conditional test execution category is basically the ones that control whether or not a test run, and container is at, basically the entire class, and test is, a condition on whether or not you want a specific test to execute. The general purpose test instance post-processor is the behavior or callback that is called after a specific instance of a class runs. Test execution exception handler is basically a callback or handler for exceptions that are thrown by any test. And parameter resolve, as the name implies, is a mechanism for you to customize the parameters that you can inject onto a JUnit 5 test method. And the test lifecycle callbacks, as you can see, they are basically tied to the main lifecycle of JUnit 5, which we're going to cover. So lastly, compatibility. This is a way for you to migrate easily existing JUnit 4 tests onto the JUnit 5 framework, or engine, I should say. And it's basically through the JUnit Vintage engine. So you don't have to actually or modify your tests against the Jupyter API, which is the new API in JUnit 5. So that's why this is provided. So forwards compatibility was a way that you could basically run your existing JUnit tests on the JUnit 5 platform engine in IDEs that didn't yet support JUnit 5. So I believe that today, as March 2019, pretty much, the modern or popular IDEs like IntelliJ and Eclipse support JUnit 5. So now you have a better understanding of the dependencies in JUnit 5 and the new architecture, as well as the new extension model in JUnit 5. Thanks for watching.